Hello, my name is Jens Poole and I'd like to show you my replica of the Antikythera Mechanism. The original was built around 2200 years ago in ancient Greece, or one of the Greek colonies that existed by the time, and around the year 65 BC the mechanism should be transported on a Roman vessel, most likely to Italy, but Poseidon had something against that. He sank the ship and the mechanism went to the bottom of the sea.
In the year 1900, the wreck was discovered by sponge divers near the island Antikythera, which is located midway between the Peloponnese and Crete. The mechanism is broken into 100 pieces, big ones and small. Since more than 100 years, scientists tried to figure out what that mechanism was, how it worked inside, and most of all, what the main purpose of the mechanism was. In the past few decades, great progress has been made. Today it is known again how the internal gear train worked, and it was also possible to decipher large parts of the inscriptions.
So let's start with the front plate.
There's a solar calendar with 365 days on the outer ring. In the original it was the Egyptian calendar. In my replica I use Roman month names instead, which are more familiar today. The yellow pointer represents the sun. It indicates the date within the year. In our case, end of March and beginning of April. The pointer also indicates the position of the sun within the zodiac. On the inner ring we have the 12 constellations of the zodiac. Currently the sun is in the constellation Pisces. The other pointer is the lunar pointer. It indicates the position of the moon in the constellations of the zodiac and shows the phases of the moon. Currently the moon is in the constellation Virgo. The moon is opposite to the sun and thus we have full moon. When you do a clockwise quarter turn of the lunar pointer, we move 1 week into the future. We have half moon now, and the solar pointer indicates that it is April. Another quarter turn and we have new moon. The moon is completely dark now. Then another half moon and then full moon again. We moved 1 month ahead. We are at the beginning of May and the sun is in the constellation Aries.
So enough with the front plate. Let's take a look around the corner. There are far more features over here.
The back plate is divided into 2 sections. On the left side are 3 calendaric displays. On top the Olympic Games pointer. One rotation of this pointer represents the 4 years of one Olympiad. The large pointer in the center and the spiral scale around it are a lunisolar calendar with 235 months, which almost exactly equals to 19 solar years. This lunisolar calendar was introduced by Metonic of Athens and is called the Metonic cycle. So let's try it out. The Olympic pointer is at the beginning of the first year of the Olympiad, and the Metonic pointer below is at the beginning of the 12th month of the Metonic cycle. When we turn this pointer 12 months ahead, 1 solar year has passed. The Olympic pointer moved 1 year further. We are now at the beginning of the 2nd year of the Olympiad. The Olympic pointer represents not only the 4-year period of one Olympiad as a measure of time, it as well indicates which panhellenic games take place in the actual year. That weren't only the games in Olympia, there were other venues as well. In each first year, the games took place not only in Olympia, but in Izmir at Corinth, in the 2nd year at Nemea and Na, in the 3rd year again in Izmir, and as well the Pythian games in Delphi, and in the last year again in Nemea, and as well in Halia at Rhodes. So let's see what the last calendaric display on the left side is. 100 years after Meton, the Greek astronomer and mathematician Callipic discovered that the Metonic cycle is slightly too long. He combined 4 Metonic cycles into his new Callipic cycle of 76 years, where the last year was 1 day shorter than the other years. Doing so, he created a calendaric system as precise as the Julian calendar, which was created 300 years later. So the ancient Greeks didn't use decades and centuries for longer periods of time. Instead, they had 3 cycles of different lengths: the 4-year olympiad, the 19-year Metonic cycle, and the 76-year Callipic cycle. Okay, enough with the calendaric stuff. Let's now take a look at the most advanced part of the machine and the coolest feature, the prediction of lunar and solar eclipses. But how does it work? Imagine we are in the year 200 BC and we are witnessing a lunar eclipse. We have full moon a few days before the spring equinox. We know that there's a cycle of 223 months after which eclipses occur again. This cycle is called the Saros cycle. Currently, we are in the 61st Saros month. We want to mark this month on the mechanism as one where a lunar eclipse occurred, and want to use this knowledge for future eclipse predictions. So, let's take a look on the mechanism now. The solar pointer indicates that we are around the spring equinox. It is Mechir 9 in the Egyptian calendar, which would be March 20 in the Julian calendar. The lunar pointer indicates that we have full moon. On the backplate we have a scale with the 223 months of the Saros cycle. It is important that we are in Saros month 61 at the moment. We just had a lunar eclipse and the moon goddess Selene was obscured. The name of the moon goddess Selene starts with a sigma. To indicate that a lunar eclipse occurred, we therefore mark the field of Saros month 61 with a sigma. We now can predict that after each full turn of the Saros cycle, a lunar eclipse will occur in the same Saros month. The next one will be after 223 months, or a little bit more than 18 years. So let's see how that works and which date most likely it will be. I'm turning the input wheel clockwise until 223 months have passed. The Saros spiral has 4 windings, therefore we need 4 full turns of the Saros pointer until we are again at the Saros month 61. Okay, we reached 61. The eclipse is 8 hours later. We are in the 2nd year of the olympiad, in the 72nd Callipic year, 45th Metonic month. We have full moon. It is Mechir 25, which would be March 31 in the Julian calendar. So the prediction is that there will be a lunar eclipse in the 72nd year of the 2nd Callipic cycle, in the 2nd year of the olympiad in Meton month 45, at full moon around Mechir 25 in the Egyptian calendar, which would be March 31 in 182 BC in the Julian calendar. The lunar eclipse we witnessed in 200 BC was shortly after midnight. The next one will be 8 hours later, therefore in the morning. And in fact, that lunar eclipse really occurred. So what's about solar eclipses? They occur as often as lunar eclipses, but are far more difficult to observe. The delay of 8 hours after each full turn of the Saros cycle makes it impossible for us to watch the 2nd eclipse after 18 years and the 3rd eclipse after 36 years respectively. Only at the 4th eclipse after 54 years we have the chance to observe it. Thank you for your attention. I hope you liked the video. Goodbye.